Hello students, hope you are doing good. Well, now in this module, we are going to discuss one of the important and interesting task. You know what it is? So recently, 2023-24 board examination has done, right? So in that, what are all the questions given from the very first chapter exclusively from functions, right? So once after finishing this, you will get to know what kind of questions you may expect in your 2024-25 board examination from functions chapter. And I have mentioned here along with the codes because this module contains all the questions across CBSE board, all the questions given from chapter functions, only from functions, right? So without wasting time, let's get into our module. See what is the very first question given. A function f from R to R is defined by f of x is equal to 4x plus 3. It is R plus to R. You know what do you mean by R plus? It was mentioned. Of course, it will be mentioned in the problem itself. R plus is non-negative real numbers. What do you mean by non-negative real numbers? Which are just not negative. Not negative means it could be either positive or it could be zero also. So that is what non-negative real numbers defined by f of x is equal to 4x plus 3 is what kind of function is dash function. Dash function means what kind of function. What kind of function means what? Of course, the options are given 1 to 1, on to, 1 to 1 but not on to, not 1 to 1, not on to. Okay, and it is a bisection. So when you are answering these kind of problems, how do you approach? First of all, you will have to check whether it is one-to-one function or not. To check whether it is one-to-one function or not, what is the working rule to check whether the function is one-to-one function or not? So now I am going with checking for injectivity. Injectivity is nothing but checking for one-to-one function. What is the working rule for one-to-one function? Let f of x is equal to f of y. You all know this. When f of x equal to f of y, then finally you have to get x is equal to y. Yes, find what is f of x equal to f of y. F of x is 4x plus 3 is equal to f of y means 4y plus 3. So that here 3 and 3 gets cancelled. Then 4x is equal to 4y. When 4x is equal to 4y, here x cannot be negative, means x square, x cube, x to the power of 4 terms are not there. So that directly you can cancel 4 and 4. Then you get x is equal to y. What do you mean by this? It means it is an injective function. It means it is one-to-one function. Is it on-to function or not? Let us check for checking for surjectivity. So what do you mean by surjective function? So in the case of surjective function, it is very simple that range is equal to codomain. So what is the codomain here? Codomain is R. Now you have to find out what is the range of this function. In order to find range of the function, let f of x is equal to 4x plus 3. This is the function given, right? Now, once you observe what is the range of this function 4x plus 3, once you observe here x is going to be positive real numbers. It is greater than or equal to 0. So, if x is greater than or equal to 0, then what about 4x? Multiply both the sides by 4. 4 into x is equal to 4x. Greater than or equal to 4 into 0 is 0. And then add 3 on both the sides. It means 4x plus 3 greater than or equal to 0 plus 3. So 4x plus 3 is nothing but your f of x, right? So f of x is greater than or equal to 3. What do you mean by f of x greater than or equal to 3? Means f of x is closed 3 to infinite. Therefore, the range of the function f of x is 3 to infinite. Is this exactly same as our codomain? Absolutely no. So that range is not equal to codomain. Since range is not equal to codomain, we can say that it is not onto function. Therefore, the given function is one-to-one, but not onto function. You understand? So this way you can answer the first problem. Coming to the second problem, you see what is the second problem given here clearly. So in the second problem, it was mentioned very clearly that f is a function defined from real numbers to real numbers, right? F is a function defined from real numbers to real numbers. And how it is defined, f of x is equal to x plus b such that f of 1 is equal to 1 and f of 2 is equal to 3, right? F of 1 is equal to 1 and f of 2 is equal to 3. Find f of x and hence check whether it is a bisective function or not. Okay, so when you check whether it is bisective or not, first of all, what is the function f of x? F of x is equal to ax plus b. And what it is given, the value of f of 1 is given as 1. 1 means what? Substitute 1 in the place of x. A into 1 plus b, which is equal to a plus b. Say therefore the value of a plus b is given 1, right? Right. And another thing is f of 2 is given 3. So f of 2 is equal to, means substitute 2 in the place of x. Then a into 2 plus b. A into 2 is nothing but 2a, right? So 2a plus b is equal to given 3. I think we can solve these two equations for a and b just by subtracting one equation from the other equation. A minus 2a is minus a. These two gets cancelled. 1 minus 3 is equal to minus 2. So minus a equal to minus 2 means you get a is equal to 2. If a plus b is equal to 1, a is equal to 2, then 2 plus b is equal to 1 means b is equal to minus 1. So the value of a is 2 and b is equal to minus 1. These are the values of a and b. After finding the function, say find f of x, we found the function f of x is equal to ax plus b, right? A is equal to 2, x plus b is nothing but minus 1. And check whether this function is bisective or not. Say this is a linear function, right? A linear function, and f is a function defined from real numbers to real numbers is always a one-to-one function as well as onto function. Therefore, it is a bisection, right? Or it is a bisective mapping. So this way you can easily answer this problem. So coming to the third problem, see what is the third problem given? Let f from r plus 2 negative 5 to infinite be defined as f of x is equal to 9x square plus 6x minus 5. Then f is dash function. Same, like you have to check whether it is one-to-one function or onto function, or both of them are not. Okay, but if you observe, if you are familiar with the textbook questions, this is one of the problems directly from the textbook. You know, in that problem, it was mentioned that you have to prove that it is a bisection. And, in the old version of textbook, you have to find inverse of the function also. And it was given that, prove that the function is an invertible function, of course. Now, we are going to check whether it is one-to-one function or not, because this problem was not just given for 1 mark, it was given for 3 marks. So when you answer this, again same, checking for injectivity or checking for one-to-one function. So when you check for one-to-one function, you'll be very clear with domain as well as codomain. Here domain is positive non-negative real numbers, and codomain is negative 5 to infinite. Okay, when you check for injectivity, what is that? Like according to our working rule, f of x is equal to f of y. What is f of x given? 9x square plus 6x minus 5 is equal to what is f of y? 9y square plus 6y minus 5. So you can cancel minus 5 and minus 5. When you transpose them to the left hand side, then it will become 9x square minus 9y square plus 6x plus 6y is equal to 0. So 9x square minus 9y square, you can take one 9 common out, and then x square minus y square would be x minus y into x plus y. Plus you can take one, so this is 6x minus 6y, right? 6x minus 6y. All right, so 6x minus 6y equal to 0. You can take one 6 common out, and then 6 times x minus y is equal to 0. Totally, how much can be taken common? Of course, x minus y. From 9 into 6 also, you can take something common, that is 3, right? So totally, 3 into x minus y can be taken common, remaining one more 3 times x plus y plus 2 into x minus y already taken out is equal to 0. So you can write it as 3 times x minus y into 3 into x plus y plus 2 is equal to 0, right? Without multiplying, just leave it like this. So then when the product of two terms is 0, either first term equal to 0 or second term equal to 0, let us go with the second term. That is 3 into x plus y plus 2 is equal to 0. From this, what is the value of x plus y? X plus y is equal to minus 2 by 3. But here, inputs are taken from positive real numbers, right? Do you know or do you find any pair of positive real numbers whose sum is negative? It's not possible, right? So that this case is not possible. So when this case is not possible, then what is the other case? Other case is 3 into x minus y equal to 0. So x minus y equal to 0, therefore x is equal to y. X equal to y, we have taken f of x equal to f of y, therefore we got x is equal to y. Therefore, this function is an injective function. Coming to surjective function. So checking for surjectivity. So when you check for surjectivity, as we already mentioned, surjective function means the codomain is equal to range. Let us try to find out what is the range of the function. Range of the function means let f of x is equal to 9x square plus 6x, 9x square plus 6x minus 5 is equal to y. You have to obtain x from this. How to get the value of x? As it is a quadratic function, so then you can make it as 9x square plus 6x minus of 5 plus y is equal to 0, right? Now I am going to use quadratic formula to find out the value of x. So x is equal to minus b means minus 6 plus or minus root over b square means 6 square is 36 minus 4 into the value of a is equal to 9 and c is equal to this entire thing. But c has a negative sign, negative of negative positive into 5 plus y. Whole divided by 2a, right? So 2a is nothing but 2 into 9. Once you observe this, minus 6 plus or minus root over this is 36 plus 4 9s are 36, 36 into 5 plus y. So 36 into 5, 5 6 are 30, 0, 3, 5 3s are 15 plus 3 is equal to 18 plus 4 9s are 36 into y is equal to 36y whole divided by 2 9s are 18. So then I'm going to write this as yes, I'm going to write this as equal to minus 6 plus or minus. See, 36 plus 180 is equal to 216, right? So 216 plus 36y whole divided by 18. From inside the bracket, I can take 136 common. So minus 6 plus or minus, when you take 36 common and make it outside, then it will be 6, right? So 6 times 36, 6 are 216 plus y whole divided by 18. Now you see this. In order to find what is the range of this function, see 6 plus y is there, no? That is inside the square root, right? When 6 plus y is inside the square root, then 6 plus y is definitely greater than or equal to 0. 6 plus y greater than or equal to 0, y greater than or equal to minus 6. So y value always minus 6 and above. Minus 6 and above means what? Y means f of x value always minus 6 and above means what? Infinite. So here, what is the range given? Range is minus 5 to infinite, right? So minus 5 to infinite is a part of minus 6 to infinite or not? Yes, of course. So obviously here, this is what is the range. It is the codomain. So codomain is the smaller set than the range. Then we can happily agree upon this particular range, because if you take any number between minus 6 to minus 5, you can take minus 5.5, of course, and then substitute in the place of y. It means 9x squared plus 6x minus 5 is equal to 5 point minus 5.5. Then you will get imaginary roots. It means there is no such x possible. Therefore, it is an onto function also. Therefore, it is one-to-one function as well as on-to function. Therefore, it is a bisection, right? So this way easily we can answer this problem. Coming to the next problem. See, it is a bit interesting problem again. Show that the function f from R to R defined by f of x is equal to 2x by 1 plus x square is neither a one-to-one function nor an onto function. So how can you check whether it is neither a one-to-one function nor an onto function? It is very simple if you observe them. Like, I'll just move it aside. Right. I'm taking function f of x and checking for injectivity. Right? See, as it is a function defined from real numbers to real numbers, and the function f of x is given as 2x divided by 1 plus x square, then how can you say that it is not a one-to-one function as well as not onto function, as it is a quadratic function? Can we say directly, because before it is a quadratic function, it is a rational function, isn't it? So how can you check whether it is one-to-one function or not? Absolutely, you do follow the working rule. What is the working rule? F of x is equal to f of y. F of y means what? 2y divided by 1 plus y square. And then simplify both of them. 2 and 2 gets cancelled. X by 1 plus x square is equal to y by 1 plus y square. And then do cross multiplication. X into 1 is equal to x plus x into y square is xy square. Y into 1 is equal to y. Y into x square is equal to x square. Y is equal to 0. Right? Now, when you simplify this, x is there and y minus y is there. And after that, from these two terms, you can take one xy common out. Xy times y minus x is equal to 0. I think totally we can take one x minus y common out. So after taking x minus y, here it is 1. This is x minus y, right? So that minus xy is equal to 0. Now I will go for the second option. What is that second option? 1 minus xy is equal to 0. 1 minus xy is equal to 0 means xy is equal to 1. It is one of the important statement that everybody has to understand. How can we use this x into y is equal to 1 in order to prove that it is one-to-one function or not one-to-one function? I'm going to do x into y is equal to 1, then x is equal to 1 by y or y is equal to 1 by x. Now I'm taking two numbers. One is reciprocal of the other. It means I'm taking any number. X is equal to, suppose, 2. Then find what is f of 2. F of 2 is equal to what? Substitute 2 in the place of x. So 2 into x is equal to 2 divided by 1 plus 2 square, right? 2 2s are 4 divided by 2 square is 4 plus 1 is equal to 5. Okay, hold on. Now I am taking x is equal to 1 by 2. And remember, x equal to 2 and x equal to 1 by 2, both are taken from the domain because both of them are inputs. Now find out what is f of 1 by 2. F of 1 by 2 is equal to 2 into 1 by 2 divided by 1 plus 1 by 2 whole square. Careful, 2 into 1 by 2 is equal to 1 divided by 1 by 2 whole square equal to 1 by 4. What is 1 plus 1 by 4? 4 plus 1 divided by 4 is equal to 5 divided by 4. What is 1 divided by 5 by 4 is equal to 4 by 5. Now see, it is 4 by 5, it is 4 by 5. What do you mean by that? It means f of 2 is equal to f of 1 by 2. What does that mean? Here, inputs are different. Inputs are different. 2 and 1 by 2 are the inputs. But we got same outputs. Means 2 and 1 by 2 both map with what number? Both map with 4 by 5. Like that, not only for 2 and 1 by 2. You can take 3 1 by 3, 4 1 by 4 or any number and its reciprocal. Both will map with only one element. I think this is enough to say that it is not one-to-one function. Right. So coming to check whether it is onto function or not. So checking for surjectivity. When you check for surjectivity, then same working rule. What is that? 2x by 1 plus x square is equal to y, right? So by cross multiplication. What do you get? Y into x square is equal to yx square. This is 2x into 1 equal to minus 2x. But y into 1 is equal to again plus y is equal to 0. Again, it is a quadratic function. So that I am using quadratic formula. X is equal to minus b means minus of minus 2 is plus 2 plus or minus root over b square is minus 2 whole square is 4 minus 4 into y is 4y square. Whole divided by 2 into a. So 2 into y. See once this is 4 minus 4y square, right? So 2 plus or minus, you can take one 4 common out and then taking outside 2 into root over 1 minus y square whole divided by 2y. Of course, 2 and 2 gets cancelled. But here I would like to tell you one thing. You know what it is? 2 into 1 plus root over 1 minus y square by y it is. See, this 1 minus y square is under the square root. As it is under the square root, then 1 minus y square should be greater than or equal to 0. And remember, y is not supposed to be 0 here because y is in the denominator now, y is not supposed to be 0. 1 minus y square greater than or equal to 0, then you can say that y square minus 1 less than or equal to 0, right? Y square minus 1 less than or equal to 0 means y value lie between minus 1 and plus 1 only. Of course, not equal to 0. So therefore, y value means this f of x value. F of x value between minus 1 to 1 not equal to 0. Means what about the other values of y? Other values of y is nothing but what? If you take y is equal to 1.5 or any number more than 1 or any number less than minus 1, then it will not be mapped. So therefore, it is not, because here codomain is real number system, but the range what you are getting minus 1 to 1 except to 0. Right? Therefore, range is not equal to codomain. Therefore, it is not an onto function. And one more part of the problem is there. Further find set A so that the given function f from R to A becomes an onto function. See what kind of numbers that you are getting. So for this problem, y value between minus 1 to 1, so that this A is going to be closed minus 1 to 1 except to 0 means minus 0. This is what is our set A. Hope you understand? Right. Coming to the next problem, fifth problem. See, in this fifth problem, show that the function f from R to R defined by f of x equal to x square plus x plus 1 is neither 1 to 1 nor onto. Also find the values of x for which f of x is equal to 3. Similar kind of problem. Is not 1 to 1 is nothing but let us go with x square, checking for 1 to 1 function. X square plus x plus 1 is equal to y square plus y plus 1. Again, 1 and 1 gets cancelled. When you transpose them, x square minus y square plus x minus y is equal to 0. Here you can write it as x minus y times x plus y plus x minus y is equal to 0. So totally you can take one x minus y common out. After that, here you get x plus y plus 1 is equal to 0. I'm taking the second condition again. X plus y plus 1 is equal to 0. Now take two numbers. Take two numbers whose sum with 1 is equal to 0. Whose sum with 1 is equal to 0 means may I take the value of x is equal to 0, comma y is equal to minus 1. So when I take x equal to 0, y is equal to minus 1, why am I taking these two? Yes. So I am finding the value of f of 0. When I find the value of f of 0, then it is going to be 0 square plus 0 plus 1, which is equal to 1. And find the value of minus 1, f of minus 1, then minus 1 whole square plus minus 1 plus 1, which is equal to what? Minus 1 whole square is plus 1, minus 1 cancel equal to 1. What does this mean? It means 0 and minus 1 both are mapping to 1. I think this is enough to say that it is not onto function. Of course, not only for these two numbers, we can take any pair of numbers satisfying this particular equation. If I take x is equal to 5 and then y is equal to how much I take 5 plus 1 equal to 6, right? So minus 6. X equal to 5, y is equal to minus 6, then it is going to be the same scenario repeats again. Both gives the same output. Therefore, it is not 1 to 1 function. And coming to surjectivity, okay, checking for surjectivity. When you check for surjectivity, range should be equal to codomain. Range is nothing but when you are finding the range x square plus x plus 1 is equal to y, then it is going to be x square plus x plus 1 minus y is equal to 0, right? So you can get the value of x is equal to minus 1 plus or minus root over b square. B square is nothing but 1 minus 4 into 1 into, so this is 4 into 1 minus y whole divided by 2 into a is nothing but 2 into 1 is equal to 2. Therefore, x equal to minus 1 plus or minus, this is 1, minus 4 into 1 is minus 4, minus of minus plus 4 into y is 4y whole divided by 2, right? So then it is going to be what? It is going to be x is equal to minus 1 plus or minus root over 4y minus 3 whole divided by 2. You can understand this 4y minus 3 is inside the square root. So 4y minus 3 is greater than or equal to 0. So that 4y greater than or equal to 3, then y is greater than or equal to 3 over 4. So y greater than or equal to 3 over 4 means y value is 3 over 4 to infinite. This is what is the range, but this range is not equal to codomain, right? So is not equal to R. Therefore, it is not onto function also. Therefore, it is neither one-to-one nor onto. So here it is given something that also find the value of x for which f of x is equal to 3. F of x is equal to 3 in the sense what? You take x square plus x plus 1 and equate with 3 and get the values of x, right? I'm going to do this now. Okay, right. May erase a part of this because anyway it was there. You are going to do for the next one. So what is that next one? F of x is equal to f of x is equal to 3. So when you are finding the value of x in which f of x is equal to 3, see f of x is equal to 3, right? F of x means 1 x square plus x plus 1 is equal to 3. It means x square plus x plus 1 minus 3 is equal to 0. It means x square plus x minus 2 equal to 0. I think this quadratic equation can be factorized easily by using splitting middle term method. So x square plus 2x minus 2 is equal to 0. So x into x plus 2 minus 1 into x plus 2 is equal to 0. Therefore, you can say that x plus 2 times x minus 1 is equal to 0. Therefore, x is equal to 1 comma minus 2. So, the values of x satisfying f of x is equal to 3 are 1 comma minus 2. Hope you understand. So, that way you can answer the problem. So, coming to the next one. So, what is the next problem? Right. See, that is fifth one. And moving on to the sixth problem. See, in this problem 6, what is the information given? Let R plus denote the set of all non-negative real numbers, R plus 2 R plus, and f of x is equal to x square plus 1 is dash function. Dash function means what? Again, you will have to check whether it is one-to-one function or onto function or not. So when you are checking whether it is one-to-one function or not, see clearly, f is a function defined from positive real numbers, sorry, non-negative real numbers, right? Non-negative real numbers to again non-negative real numbers. F of x equal to x square plus 1. So this is checking for injectivity. When we check for injectivity, then you can say f of x is equal to x square plus 1, which is equal to f of y. I'm writing directly y square plus 1. X square plus 1 equal to y square plus 1, 1 and 1 gets cancelled. X square is equal to y square. Then you can write, you cannot write directly as x equal to y because x square minus x square equal to y square means x square minus y square equal to 0. It can be written as x minus y into x plus y is equal to 0. Going to the second condition, x plus y is equal to 0, then x plus y equal to 0 means what? Sum of two numbers is 0. Sum of two numbers 0 means definitely one of them is negative, right? But they are not available here in our domain. Therefore, it is not possible case. Therefore, what is the second case? X minus y is 0. Therefore, the value of x is equal to y. F of x is equal to f of y. Therefore, x equal to y. Therefore, it is one-to-one function or injection. Coming to checking for surjection. So, in the case of surjection, you have to take f of x is equal to x square plus 1 is equal to y. Range should be equal to codomain, right? So x square plus 1 equal to y, then you can say that x square is equal to y minus 1. X square equal to y minus 1 and x equal to what? Plus or minus root over y minus 1. But x being positive, non-negative real number, negative number is not possible. Therefore, the value of x is equal to root over y minus 1. It is only possible when y minus 1 greater than equal to 0. Y minus 1 greater than equal to 0 means y greater than equal to 1. Y greater than equal to 1 means what is that y or f of x? F of x equal to y belong to 1 to infinite. Is this 1 to infinite is exactly same as r plus? No, r plus is nothing but what? R plus means closed 0 to infinite. Isn't it? Because non-negative real numbers, right? Then see, all the elements will be mapped except the elements from 0 to 1. Of course, 1 can be mapped. The elements from 1 means closed 0 to open 1 will not be mapped. So therefore, here range is not equal to codomain. Therefore, it is not a surjective function. As it is injective function, but not surjective function. Right? Good. Next, moving on to the next problem. F of x is equal to x cube minus 1. Same kind of problem here. Okay. So the problem given here is f of x is equal to x cube minus 1 and f is a function defined from z to z. Z is nothing but it's a real number, integers, right? Now checking for one-to-one function. How to check whether it is one-to-one or not? F of x equal to f of y means x cube minus 1 equal to y cube minus 1. So minus 1 plus 1 cancel. X cube minus y cube. X cube minus y cube equal to 0. What is x cube minus y cube equal to 0? Can we directly write it as x equal to y? No, you cannot write. Because it is x cube minus y cube can be expressed as x minus y into x square plus xy plus y square is equal to 0. I am taking the second condition, that is x square plus xy plus y square is equal to 0. And x square plus xy plus y square is equal to 0. It is not actually possible for any two values of x and y are integers. Because x square is always greater than 0 and y square is always, greater than or equal to 0. Y square is also greater than or equal to 0. And coming to this xy value under the set of integers, x square plus y square value always greater than x into y. So therefore, it is not possible. Therefore, second condition is not possible. Since the second condition is not possible, what is the first condition? X minus y equal to 0, x is equal to y. Yes, therefore, f of x equal to f of y, you got x equal to y. Therefore, it is one-to-one function. Coming to surjectivity. In the case of one-to function, f of x is equal to x cube minus 1 is equal to y. X cube minus 1 equal to y means x cube is equal to y plus 1. Then x is equal to 1 cube root over y plus 1. Now you see here, x is cube root over y plus 1, right? Means all the numbers are not cube numbers, right? They are not perfect cubes in integers. Suppose if I take f of x is equal to 2. If I take f of x is equal to 2, then what is the value of x here? It means x cube minus 1 is equal to 2. Then x cube is equal to 3. Then x is equal to 1. X is equal to cube root of 3. This cube root of 3 does not belong to set of integers, right? It is not possible. What does that mean? You can map only cube numbers means the perfect cubes in the codomain. So what about the numbers which are not perfect cubes? They will not be mapped. It means range is not equal to codomain. Therefore, it is not onto function. Therefore, it is a one-to-one function, but not onto function. Right? Fine. Coming to eighth problem. See what is the problem 8 given here. In this problem 8, let A is equal to R minus 3 and B is equal to R minus A. Find the value of A such that F is a function defined from A to B. A to B means what? Real numbers minus set containing 3 to real numbers minus set containing A. And how that function f of x is defined? F of x is equal to x minus 2 divided by x minus 3. Right? Now, find the value of A such that f from A to B is defined as onto function. Okay, so onto function in the sense what? When you are checking for onto function, let it be y. It is onto function, right? Onto function, let's go with the working rule. X minus 2 by x minus 3 is equal to y. Y means y by 1. Do cross multiplication. Y into x is equal to xy minus 3y is equal to x minus 2. Since you are obtaining the value of x, transpose x to the left hand side and 3y to the right hand side, then it will become xy minus x is equal to 3y minus 2. You can take x a common out. X into y minus 1 is equal to 3y minus 2. X into y minus 1 equal to 3y minus 2 means x is equal to 1, 3y minus 2 divided by y minus 1. See, here y minus 1 means what? Y is not supposed to be 1. And y can take any number except 1. Any number except 1 means what? Y is equal to real number system. Y belong to real number system minus 1. See here, what is that B? B is real number system minus A, which is equal to real number system minus set containing A. Can you tell me what is the value of A now? A is equal to 1. Right? For B, set B is equal to R minus set containing 1, it is an onto function. Right? And also check whether the given function is one-to-one function or not. Now it is easy to check whether it is one-to-one function or not. Checking for one-to-one function, you know f of x is equal to f of y. F of x equal to f of y means what? X minus 2 divided by x minus 3 is equal to y minus 2 divided by y minus 3. By cross multiplication, x into y is xy minus y into 2 is equal to 2y minus x into 3 is equal to 3x minus of minus 6 is equal to, again x into y is xy minus 3 into y is 3y minus 2 into x is 2x plus 2 3 is 6. See, some terms can be cancelled directly. Minus 6 and plus 6 gets cancelled. This is minus 2y minus 3y, right? So transpose minus 2y that side and x terms this side. Already minus 3x, this is plus 2x. So minus 3x plus 2x is equal to 1. This is minus 3y minus 2y will become plus 2y. So minus 3x plus 2x is equal to minus x is equal to minus y. It means x is equal to y. Therefore, it is a one-to-one function. Right? So this way, you can check whether this function is one-to-one function or not. And coming to the next problem, see ninth one. A function f from R to R defined by f of x equal to x square minus 4x plus 5 is dash function. Again, you will have to check whether it is one-to-one function or not. Already we discussed about a quadratic function, whether it is one-to-one function or not, correct? So as it is a quadratic function, how to check whether it is, of course, we know that it is not one-to-one function, but how do you verify whether it is one-to-one function or not? Sometimes you will be asked the question, show that it is not one-to-one function by using a suitable example. Then for the working rule, it is checking for one-to-one function. F of x is equal to f of y, right? F of x equal to f of y means x square minus 4x plus 5 is equal to y square minus 4y plus 5. Again, 5 and 5 gets cancelled. X square minus y square minus 4x plus 4y is equal to 0. X square minus y square is x minus y times x plus y If you take minus 4 common, then it is going to be x minus y is equal to 0. So totally you can take x minus y times x plus y minus 4 is equal to 0. I am taking the second condition again. X plus y minus 4 is equal to 0 means x plus y is equal to 4. Now you can take two numbers whose sum is equal to 4. I am taking x is equal to 1, y is equal to 3. Now find what is f of 1. F of 1 is equal to 1 square minus 4 into 1 plus 5 is equal to 1 minus 4 plus 5. So which is going to be how much? Going to be 2. And similarly, find f of 3. F of 3 is equal to what? 3 square minus 4 into 3 plus 5. So 3 square is equal to 9 minus 4 3s are 12 plus 5. So which is equal to 9 plus 5 is 14. 14 minus 12 is equal to 2. What does that mean? 1 and 3 both are mapping with 2. Right? So this way easily you can check whether it is one-to-one function or not. Therefore, it is not one-to-one. Similarly, to check whether it is onto function or not, so checking for surjectivity. When you check for surjectivity, same thing, same working rule. X square minus 4x plus 5 is equal to y. It means x square minus 4x plus 5 minus y is equal to 0. I'm using the quadratic formula. X is equal to minus b plus or minus root over b square is minus 4 whole square is 16 minus 4 into 5 minus y. 4 5s are 20 minus of minus plus 4 into y is equal to 4y whole divided by 2a is 2 into 1. Right? So now this is going to be 4 plus or minus root over, this is 4y minus 4, right? 4y minus 4 whole divided by 2. If you take one 4 common out and then 4 into y minus 1, so that y minus 1 should be greater than or equal to 0, y greater than or equal to 1. Y greater than or equal to 1 means what? Y value belong to closed 1 to infinite means it will not give the values below 1. So this is not exactly same as real number system. Therefore, it is not onto function. Therefore, it is neither one-to-one nor onto function, right? So coming to 10th problem, this is a quite self-explanatory problem because it's a straightaway textbook and we discussed one problem earlier. I'll show you which problem that was we discussed. Okay, this is the 10th problem is exactly same as, yeah, this is the problem. Right? So hope you understand and enjoy. You have to be more focused because in one particular exam, you can see 10 problems from exclusively functions. Right? So when you are answering these kind of problems, be very much careful because it is, everybody knows and you come to one conclusion that if it is a quadratic function, then it is not one-to-one function. But if it is just x square, f of x equal to x square, then easily you can identify minus 1 plus 1 minus 2 plus 2, these kind of things. But if it is a complete quadratic polynomial function, while checking whether it is one-to-one function or not, while checking whether it is onto function or not, then how to check, that only matters. So hope by this module, everyone could understand how to check whether it is one-to-one function or not, and what kind of questions you can expect in the upcoming 2024-25 board examination from the chapter functions, right? Thank you very much.